right, so the last thing we're going to look at in regards to organizing and visualizing quantitative data are distribution shapes. So once we've created our histogram, what does the shape of that histogram look like? So there are four main shapes that we're going to look at. Three of them we're going to see more. This first one that we're looking at, we're not going to see that one too much, but it is one of the ones we want to look at. So the first distribution shape is a uniform distribution. This is where the frequency of each value for the variable is the same. This distribution is symmetric, meaning if I cut it in half, so if I cut it in half right here, it looks identical on the left and right side. I could fold it in half and everything would line up. Some examples of uniform distributions are the outcomes when you're rolling a die, or the suit you get if you randomly draw cards. So uniform distributions are seen a little bit more when we talk about probability. They're not so much seen in the natural world. Okay, so another type of distribution is the bell-shaped distribution. In the bell-shaped distribution, the highest frequency occurs in the middle of the graph, and the frequencies tail off from the left and the right. This distribution is also symmetric. So one of the things that we'll see if we're talking about a bell-shaped distribution is sometimes we won't have the histogram. Sometimes we'll say, oh, it's bell-shaped, so it looks like this. This is the highest point and it's in the middle, and then it tails off on the left and the right-hand sides. This is the most common distribution that we see in the natural world. It's also known as the normal distribution, and it's going to become your BFF. And you don't believe me yet, but you will. So some examples of things that are bell-shaped are heights, birth weights, and SAT scores. There's so many other things that I couldn't possibly list them all, but these are three of the main ones. So this is our bell-shaped distribution. And then we have a skewed right distribution. So in a skewed right distribution, the highest frequency occurs to the left of the middle, and the graph has a long right tail, which is why it's skewed right. So if we were to draw this curve, this graph, without actually looking at a histogram, it would look like this. So we've got a long tail happening off on the right-hand side. So a couple examples of things that are skewed right are wealth. Most people are down, in the lower part or middle class, and then you have those few people that are super rich that are way off on the right-hand side of everything. Another one is household size. Most people have a household size between 1 and 4, but then you have some large families, like the Duggars. I don't know if anyone here knows who the Duggars are. 18 kids and counting. They had a household size of 20 at one point. So they make it look skewed right. That's a skewed right distribution. And then skewed left is the opposite. So the highest frequency is on the right of the middle, and the graph has a tail on the left. So that guy, as a curve, looks like this. And these curves are just kind of generalizations of what this distribution looks like. So some examples of things that are skewed left is retirement age. Most people retire in their 60s or 70s, but you have a few people that retire early. Another one is human lifespan. Most people live to between their 60s, 70s, 80s. They're grouped in those higher ages. But then, as we all know, there are those that die young, but there are much fewer of those that are dying young than those that are dying older. So one thing to remember with these skewed distributions, if we talk about skewed right or skewed left, we're always talking about it in terms of which side of the graph has that long tail. So skewed right, long tail on the right. Skewed left, long tail on the left. It's not where the bulk of the data is. And that's an important thing to remember. So we have our 4 distribution shapes. Some of these we'll see a little more often than others. And that's it.